Okay, now we're going to go on to Rule 3A. So, again, we're looking at this to factor, but we want to go through all of our factoring rules. So, rule number 1, any greatest common factors. Well, these don't even have numbers, so we can't factor out a number. And this one doesn't even have a letter, so we can't factor out any letters. So now we go on to Rule 2. Let's look at our questions on the back. Rule 2. Is this a binomial? The answer is no. So then we go on to question number 6. Is it a trinomial? Well, the answer this time is yes. 1, 2, 3 terms. So this is a trinomial. So now we go on to question number 7. Is this sign right here a positive? Well, that answer is no. And then it tells us to go back to Rule 3A. Okay? So, we'll talk in just a little while exactly how to tell whether it's 3A or 3B. But 3A basically means that this is our squared term, and the coefficient, the number in front of this term, is a 1. So if this is a 1, and this is a trinomial, then this is the only place you can do this. Never ever do it anywhere else, but you may start with a double bubble. I don't like the way that came out. What I call a double bubble. Okay? Do not ever start with a double bubble anywhere else. We always end up with 2 sets of parentheses, but do not start with it anywhere else. Okay, so the first thing I'm going to do is take the k and put one of them in the front of each. So k times k is k squared. Now, the next thing we're going to do is take this number, which, what is it again? 1, and then this number, always positive, okay? Because we're going to take care of signs in a different way. So 1 times 56, do this way over on the right side of your paper. Now, find all the factors of 56. The way to do that, and make sure that you get them all and you don't miss any, is to start with 1, 2, 3, 4, etc. So 1 times 56, 2 times 27, 3 does not go into this, so I don't write it. 4 does not go into this, so I don't write it. Yes, 4 does, actually. 14 times. 5 does not go into this, so I don't write it. 6 does not go into it, because 2 and 3 didn't. And then 7 is the next one. 7 times 8. Well, I know I'm done doing this when either both of these numbers are exactly the same, like if this had been 36 and that was 6 and 6, or if the next number I'm going to write, in this case the next one I would write would be 8, I've already written, then I know I've got them all. And now what I want to do, I can only use these in the pairs that they are, the 1 and the 56, or the 2 and the 27, or the 4 and the 14, or the 7 and the 8. What I'm looking for is to use one of those pairs and to add them together in any combination of signs and get a positive 1, this middle term. So that is going to be, in this case, the 7 and the 8. So the next thing we want to do is figure out which sign belongs in front of which number. So I'm going to say -7 and +8. Always write these down. Then the next step, and this is critical, it'll save you time and headache. Cover this up, look at those two, add them together, see what you get. That's an addition problem whose signs are different, so you subtract the small number from the big number, keep the sign of the big number, you end up with +1. Now you can look here, and if that's what you need, then we've got a good combination. We don't know yet, though, whether it's the right one. We have one more thing we have to do before we know for sure that this is what we're going to use. So the last thing to do is multiply your signs. not your numbers, just your signs. So negative times a positive is a negative, and if that's what this sign is, then this is the pair that we use, and we just take these now and drop them in, and we are done factoring this. Let's look at another one. Okay? Again, need to be factoring. So rule number 1, any greatest common factors. First thing I'm going to do is look at my numbers. Well, the most I can get out of this guy is 5, but I can get 5 out of this one, and I can get 5 out of this one. So I can factor a 5 out. Now everybody has at least one y. This one only has one y, so I can factor a y out as well. Now I need to see what's left. So that would be y squared minus 3y minus 4. Okay, now whenever you factor a greatest common factor out, you must look at what's left and see if it can still be factored. So we go on to rule 2. Is this a binomial? Nope. So we go to question number 6. Is it a trinomial? Yes, it is. Question number 7. Is this sign, the second sign, positive? No, it's not. So it's not a perfect square trinomial. And so then we go back to rule 3. Because it is a trinomial, and rule 3 is all about trinomials. Well, this one has a 1 coefficient. So that means that this is rule 3a. So always bring down anything that you've factored out. We don't do anything more with them, but we keep bringing them down. Double bubble, a y and a y. Okay? Now I take a 1 and a 4 way over on my side of the paper, multiply them together, find all my factors, 1 times 4, 2 times 2. Oh, that means I've got everybody. So I need to see which pair here, when I add them together in any combination of signs, will get me a negative 3. Well, that's going to be this. So I think it should be positive 1, negative, 4. Okay? Now, again, cover this up. I know you think that's silly, but I can't tell you how many times if you don't cover this up, if this is wrong, you will make it be whatever this is anyway. So if you cover it up, all of a sudden we don't do that anymore, and we'll discover whether it's wrong or not. So cover that up, add these together. You're going to, in this case, get negative 3. So we're good there. Last critical step, make sure you're always doing both of these. Positive times a negative is a negative. That's what this is. And so I'll take these, plop them in, and now it's fully factored. Okay, that's the end of this one. See you on the next one.